Well, welcome, you guys. My name is Lisa, and I'm a software engineer for Amazon Web Services. And I've been a developer in the mobile space for about 2.5 years, a little over than that. I've worked on SDKs and services that developers use to build mobile apps using AWS.
I'm Tomas Bataya. I'm a software engineer at Goodreads. I've been at Goodreads for over 3 years, working on roles in the front end, back end, and currently the iOS team. So in this session, we're going to show you how we at Goodreads go from idea to customers with one of our recent app features. And then Lisa, in the second half of the session, will show you how you can do the same thing using AWS technologies. So let's get right down to the app lifecycle that we have at Goodreads. So Goodreads is a site for book lovers. It launched in 2007 with the belief that the right book in the right hands at the right time can change the world. We have apps on iOS, on Android, and Kindle. And our apps and our website offer our users a place to track what they're reading, see what their friends are reading, and get recommendations from all different kinds of content. And we have lots of content. So given all the content we have and all the different platforms we surface, we have lots of different ways that we can achieve our company's mission. And so we come up with ideas that will achieve our mission and fall into the life cycle you see here. I'll jump into one of those recent ideas and how we go through that life cycle. So first, it starts with an idea. We research. We look at product metrics. We look at customer feedback. We look at user testing, and we pay attention to what our users are saying. So for this particular feature, we heard from our customers that they like using Goodreads, but really wanted the Listopia feature brought into the app. If you're not familiar, the Listopia feature is a bunch of user-generated lists that users can assign books to. So lists such as best books of the 20th century or best paranormal romance. So it's a great discovery tool. You finish a book, you see what list it's on because you really love that topic, and you can find your next book from there. So from there, we moved into our design phase, which is more than just the UI. It's also about software design. So we got our mocks from our designer, and we saw that this was a pretty simple view to create and product specific. I'll jump into that, what that means in a bit. And since we were missing it on both our Android and iOS apps, we decided that this was a perfect use case for React Native. And on the data side, we had our APIs, but we realized we had a problem with how to fetch it. So I'll cover that in a bit. But first, why did we decide to go cross-platform for this feature? So using a cross-platform solution, there's no need to repeat work to implement the same feature on both surfaces, especially if your feature is following design constructs specific to your product and not as much on the native construct. Cross-platform can also allow us to ship new features faster, which decreases the cost of development. React Native solution also lets you send out over-the-air updates without your users needing to update the apps. Sending out critical hotfixes and minimal feature updates are able to be done without your users having a dependence on updating from their respective app stores. And finally, there's very large open source community support for React Native, which means it's a good sign for its future. And it's not a good feeling to onboard onto an open source technology that doesn't have such a vibrant community behind it. By the same token, there are some cases you might not want to go cross-platform. So using React Native specifically, this means that your dev team will need to add a new language to their tool belt. And like I mentioned earlier, you can ship faster, but bringing in React Native is almost like maintaining a third app. So be careful with that. And finally, there are some documented issues in integrating React Native to your app. Android specifically has most of these problems. For example, iOS ships with its own JavaScript core engine, but Android does not, so React Native will bundle it in for you. But then when you attach a Chrome debugger and you're troubleshooting, Chrome will attach its JavaScript core engine, so you might see inconsistencies as you're debugging. With all that said, we decided to use React Native for this new list feature. So the next part of design was fetching our data. So these are all the round trips our client would have had to make to populate the UI given from our designer. So these round trips are first a list of book lists where we'll get a list of IDs, which our client can then use to resolve to get the book list metadata. The book list metadata was necessary to show the title of the list as well as the number of books on that list. That same ID can then be used to fetch the books on the book list. That API similarly returned a list of IDs. We then need to fetch the book data with that ID to show the cover image. So we had that nice 5-book cover carousel view. So we realized that this was a problem and we wanted to solve it. And so when we look at using new technologies to solve our needs, we analyze several factors before bringing it into our tech stack. So this first one seems obvious, but it's important to ask. We want to make sure that the technology actually solves our problem. If it only gets us halfway there, it's not worth it. And we have a ton of users and a ton of content. We are continuously growing, and any technology or service we use needs to match our growing needs. Another factor is whether we get to focus on our core product. Anything that helps us do more of our business logic and less ops is a plus. And then with a microservice architecture, it's important that we present a consistent interface and data for our front-end applications. And finally, is it fun? You might not think this isn't too important, but you'll get a lot more out of your developers if they enjoy working with the technology. So after evaluating those factors and others, we came to the conclusion that GraphQL would solve our needs very well. GraphQL is a query language for APIs. It provides a complete and understandable description of the data in your API. While typical REST APIs require loading from multiple URLs, GraphQL APIs get all the data your app needs in a single request. And its type system gives us the consistency we were looking for. But GraphQL is a backend service that your team would need to run ops for. You would need to have a server and install a runtime. So we didn't want to do that. One of our requirements was minimizing ops. So we looked around and saw that AWS provided a managed GraphQL service called AWS AppSync. So that solved that need for us. And so with AppSync, we're able to reduce the round trips our mobile clients have to make to just one. And given that the latency from coast to coast is about 80 milliseconds, removing 3 of these alone is a 240 millisecond savings for a client on the opposite coast from one of our servers. And never mind the additional benefits of making fewer calls and likely poor network connectivity. AppSync also solved all the factors I mentioned earlier. It's AWS, so you know it scales. Its GraphQL implementation gives us a consistent interface for our apps, and it's fun to use. Also with GraphQL, we just have to worry about books, lists, authors, our business logic. So next we move into developing, and the first part about that is scoping the work. We estimate it, we split the units of work, and we use a tool to keep track of these tickets across our teams so we're not stepping on each other's toes. We like to make use of test-driven development. We write the tests first, then write the code to pass the tests, refactor that code, and then repeat. React Native's ecosystem makes this really easy to do. And so we were able to write lots of unit tests for our Listopia feature. We also have sandbox environments, both front-end, our app, as well as back-end, the server APIs, as well as AppSync. We also have pre-prod and production environments for when the code has been pushed. And before any code from development gets pushed, though, we have it reviewed by other team members. When you have several people and maybe several teams all contributing to the same repository, having a code review process can avoid duplicated work and keep people abreast of incoming changes. So at Goodreads, we use a pipeline to manage this deployment process of our backend and the AppSync related code. So first things first, we run those tests. And if any of the tests fail, we know that we can't proceed, so the build breaks, and the deployment is blocked until the test failure is addressed. After tests pass, we move that code into beta environments, and these environments are available for other services to run integration tests against, and for the service itself to run its integration tests. So if we fail, we know that an API contract has been potentially violated, and we need to address that. So with AppSync, we make sure we get the correct responses for all of our underlying data sources. And if those fail, we know that our existing queries out in the wild will fail too if we continue with the deployment. And in some services, we may use what's called a canary. This environment is just one host of the production fleet that holds new code. We let this marinate a bit and alert on any metrics going south compared to the rest of production. So after that stews a bit and it looks good, we release that code into the rest of our production fleet. So that was testing for the backend and AppSync related code. We do lots of testing for the front-end application, our iOS app. So we have a QA team that runs through user stories to make sure our releases don't impact the current features, and they run through new user stories for the new features as well. They like to automate these flows as much as possible. And they work with us to figure out what the next release will contain, and they come up with a test plan to test those features and the existing ones. So for the list feature, they worked with us and our designer to figure out what were the expected flows and expected states. And additionally, if you're lucky, your organization will overlap really well with your app's audience. So having your employees test the newest features out for you can be really great too. So after QA certification, we post the new app version to the respective app stores. And in some cases, we may also have a PR push. But the story doesn't end there. After release, we want to track our app's operational and business metrics. So here are some of the metrics we like to track. So crashes, number one. Nobody likes an app that crashes on them. And so this count is the #1 operational goal on the mobile team. We also like to track the average and P99 latency of our APIs. P99 means the top 1% slowest. Noticing these are going up means that your backend is not scaling. We also like to track errors. Some amount of client errors are to be expected, but too many or too few can indicate a problem. So as an example, in the case of authentication, there's a baseline you expect of failed password attempts, 400 errors. And if the number of these client errors, though, is higher than your baseline, there might actually be a problem with your server code. Or if you have too few, maybe you're not tracking metrics properly. Server error codes, on the other hand, should have a much lower threshold to alarm than client errors. And finally, knowing when your peak traffic comes in, either time of day or specific time of year, such as the holidays, can help with scaling your backend so that your latency doesn't suffer and hence your user's experience. And so we also track several business metrics. Here are a few of them. Shelvings. Goodreads, since Goodreads is for our users to track what they want to read, what they're currently reading, what you've read, and more, it makes sense for Goodreads to track this core component. You'll want to make sure you track metrics related to the core component of your business as well. We also like to know how many users have an account, how many active monthly users we have. And finally, we like to know which views are worth investing in. Tracking where eyeballs are going helps us understand what our users find valuable. On both business and operational metrics, depending on the criticality of them to your business, you'll want to set up an on-call rotation to respond to any of these alarming. Fortunately, with React Native, we have the ability to send out over-the-air updates without needing an app date from our users, while on the back end, we can respond without obviously needing a client update either. So finally, we jump into improving. We look at several factors. We look at the feedback we get via social media, via email, via our feedback group. We look at how metrics are doing and make any tweaks there. So with our lists feature, knowing that lists resonate really well with our users, we went ahead and added this component to our book pages, repeating the process and lifecycle from our first iteration. So this is a book page on our app. And so we added that same React Native component inline at the bottom of lists featuring this book. So if you've just finished this book, you can see what lists it's on as well. So from there, we just jump right back into our little flywheel here, back to design, and so on and so forth. So now Lisa will jump through and show you guys how you can do so yourselves using AWS technologies.
Thank you. So let's just first start with an idea. How many times have you guys had an idea for an app, but just didn't know how to start it or how to build one? Well, I also have an idea for an app. I want to build a translation app because whenever I had to translate from Korean to English and vice versa, it was always kind of awkward and funny, just didn't make sense. So I just want to build a translation app. So I'm going to start thinking about how I want to design my app. Well, do I want to build a chat app, photo sharing app? No, I want to build a translation app. So I want to have support for multiple languages. So I'm going to have French, Portuguese, and Spanish buttons, and a text box that contains a sentence that I want to translate. And I want to also have a text box that contains a translated sentence, and a button that triggers the whole translation. So I know what I want to build. I know how I want it to look like. Now I got to start thinking about what platforms I want to support. There are 3 choices: iOS, Android, and I could use React Native. Thomas gave you a few pros and cons about going cross-platform. I'm going to be using React Native to go cross-platform as well because I think that's pretty cool. You know, just having the feature parity across Android and iOS with a single JavaScript knowledge, that's pretty awesome to me. And also, I love the over-the-air update capability. With that capability, I can be agile and quickly push out new features without forcing my users to update their app. And because I'm just starting out, I might be introducing a few issues here and there. So it would also allow me to patch my app pretty quickly. So when you start building an app, it's important to start thinking about your MVP, meaning that's your minimal viable product. What is the minimum bare necessity that you need to make your app function? For my app, it needs to be able to take a sentence and a language and return a translation in that language. So I'm going to be using the cloud to do my translation service because, frankly, doing that kind of logic in my app it can get really hard to manage with all the code I have to write and manage, and it would prevent me from being agile. So I want to be able to send a request to the cloud where it has a sentence in a language, and I expect back a response to translation. So I've laid out the foundation of what my app is, how it's going to look like, what platform it's going to support, so we can start building it. First, I want to think about my domain object. My input is going to be consisting of a sentence and a language, which are both strings. And my output is going to be a sentence, which is also a string. And I'm going to be using GraphQL to build my app because it supports strong typing, which is pretty important to me. With strong typing, I know exactly what queries or mutations or fields my API supports. And it has queries, mutations, and subscription support, where queries let you read data, mutations let you write data, and subscriptions are to push data in real time. So subscriptions let you listen to any changes that are happening in the back end. And it also allows clients to specify the shape of the response. So if the client's like, I want a list of all the posts, but I just want the title, the server will just return just that field. So that kind of allows the clients to be flexible and allows the clients to decouple the backend server service knowledge, which helps it to be efficient as it saves on the bandwidth in the interaction and also saves on the compute power on the server. So I could build my own backend service fronted by GraphQL, but that would mean I need to build my backend from scratch, which would include authorization, security, fan out, scaling, subscriptions, and the list just goes on. Running a GraphQL server myself is an undifferentiated heavy lifting, and I don't want to have to manage that backend myself or operate the backend myself. I just want to focus on building my app so that I can leave the undifferentiated heavy lifting of operating the infrastructure to AWS. So there's AWS AppSync, as Thomas mentioned earlier. It's a managed GraphQL service. It's a managed serverless GraphQL service to interact with application data that supports GraphQL queries, mutations, and subscriptions. It connects to AWS resources in your own AWS account, allowing you to make the data available in real time and offline. Right now, it supports AWS Lambda, Amazon Aurora, Amazon DynamoDB, and Amazon Elasticsearch Service. And also, it allows you to connect to your own HTTP endpoint if you have one. And you can also use AppSync as a facade to any AWS service through Lambda as well. And AppSync integrates with AWS IAM, Cognito user pools, or you can even use API keys, providing really powerful options to secure access to your API. You can also use external OpenID Connect providers to authenticate and authorize your GraphQL calls. AppSync lets you get your data in real time from any API or data source, thus quickly adding liveliness and pub/sub capabilities to your applications. It also lets you make the data available offline in your apps so that the app can function even with limited or no network connectivity. Offline data usually leads to data conflicts, so AppSync also provides the ability to handle these conflicts both on the client and the server using multiple built-in and custom strategies. And all these capabilities are available to you through the AppSync SDKs for JavaScript, React Native, Android, and iOS. And you can use AWS Amplify to build your backend. It's a comprehensive library for developers who use to build their cloud-enabled mobile apps using AWS. But it's also a toolchain built for developers. It makes it really easy to use a cloud, and I'll be using AWS Amplify later in the presentation, so you get to see that. So before I demo building my app, I want to quickly explain what I'll be doing and a few concepts. So I'm going to be using AWS CloudFormation to manage my resources in the cloud. CloudFormation provides a common language for you to describe and provision all the infrastructure resources in your cloud environment. It's best practice to manage your resources with CloudFormation because it allows you to model your entire infrastructure in a text file, provisions your resource in a safe, repeatable manner, allowing you to build and rebuild your infrastructure and applications without having to perform manual actions or write custom script. And codifying your infrastructure allows you to test your infrastructure just as code. And in this demo, I'll be using AWS AppSync along with AWS Lambda as my data source to do the translation. AWS Lambda lets you run code without provisioning or managing servers, and you only pay for the compute time you consume. And my Lambda function, it's going to be using Amazon Translate, Amazon Poly, and Amazon S3, where Amazon Translate is a neural machine learning translation service that offers language translation, and neural machine learning translation is a form of language translation automation that uses deep learning models to deliver more accurate and more natural sounding translation. And Amazon Poly is a text-to-speech service that uses advanced deep learning technologies to synthesize speech that sounds like a human voice. So I want to just show you guys my Lambda function. Awesome. So this is what my Lambda function looks like. I have voices for each language. So first, I'm just going to be preparing the parameters that I need to translate, to be able to use Amazon Translate. So this block right here is just doing the translate. And with the data it receives, it's going to use Poly to synthesize the speech. And then it's going to use S3 to upload the synthesized speech, and then it'll return back the S3 key and the translated text. So that's my Lambda function. And I want to quickly explain my app code as well. So you can see that there's 3 language buttons and 2 text boxes and a translate button. So these are my buttons: French, Portuguese, Spanish. And I have my button groups. So this is the top button, the language buttons that you saw. And these are the 2 text boxes. This is the text that you want to translate. And this one holds the translated text. And this one is the button that does the actual translation. So like I mentioned, this is my CloudFormation doc. I have my IAM policies and my Lambda function right there. And I already went ahead and uploaded my Lambda function to my S3 bucket. And I have my AppSync related resources. Now using this CloudFormation doc, I can upload it to CloudFormation to manage my cloud resources. So I'm just going to go through and click next. So what it's going to do is create all those resources. And I did skip the whole creating part just to save some time. So we can take a look at all the resources that it created. And let's just take a look at the Lambda function. Cool. So that's the Lambda function that my CloudFormation created for me based on the text file. So it looks like that is the correct one that I just showed you. So we now have a fully functioning app, so we can kind of start testing it. There are many ways to test your app. There's local testing in simulators and emulators, and there's also functional testing. And there's user experience testing and real device testing. And when you're testing, especially app testing, it's important to think about all the different form factors that are out there. And real device testing is pretty important when you're trying to deliver quality applications, but it's difficult because we don't always have access to every device that's out there. It's really hard. But you can use AWS Device Farm to test your Android, iOS, and web apps on the cloud. So let me just show you how that works. I'm just creating a Device Farm project. So I'm just going to create a new run. I already went ahead and bundled my app and created an APK file. So I'm just uploading that. And what it's doing right now, it's just parsing through my application. So cool. Just going to click next. And there are different kinds of testing, but I'm just going to use the built-in Explorer testing. That'll just go through all of the screens that are available in my app and just make sure that there's not crashing or anything. And you have a choice of using top devices or your own device pool, but I'm going to be using the most popular devices. And you can also choose to add extra data or even install other apps if your app opens like Facebook or Twitter. And you can also mock your location and change around the network setting. I'm just going to keep it at full for the demo purposes. I'm just going to click next. Yeah. So it created a new test run for me. Awesome. And so those are the devices. It's currently waiting on them, and as soon as it gets the instance of the device in the cloud, it'll immediately run the test. So it looks like the Google Pixel 2 finished just fine. So let's just wait for the next ones. So 3 of them are already finished. But I did go ahead and skip a lot of this because it does take a while for the test runs to finish. So you guys don't have to sit through like 15 minutes just looking at this. You're welcome. So it should almost be done. We just have the Gasky tab left. So all my tests finished just fine. So after the tests are done running, you get all the screenshots from each of the devices. So you know exactly how your app looks on different devices. And it's pretty important, especially with like a tablet where the screen size is pretty huge. So you can click on a test run to see the actual video of the test run. So it just opened up the app, and I only have a single view, so it's not that fun. But you also get logs of your test runs, which is awesome. Just in case your app does crash, you get all the logs on why it crashed. And you also get performance, different files that you might have had, and of course, screenshot again. So that was pretty cool. So now I kind of have confidence that my app is working and it's pretty stable. So we can start giving it to our customers. But right now, my app only has a single endpoint, which is not very good because my development process might negatively impact our customers. So it's best to create 2 separate stacks, one for development and one for production. So you can develop and maybe experiment in your development stack without impacting your production customers. And it'll be great to achieve some kind of a continuous deployment here where I'll be developing and pushing it to my development stack, and that'll automatically run the test maybe in device farm. And only when the test passes, it'll automatically push it to production, making it immediately available for my customers. So now we have our customers using it and loving my app. So now I want to start thinking about my operational metrics. As Thomas mentioned, it's important to track your crashes, latency, client and server errors, and your transactions per second. But all of these metrics can be collected using Amazon CloudWatch. You can monitor your resources and applications. And with those metrics, you can set a certain threshold and an alarm so that when the threshold is breached, you'll be notified immediately so you can fix the issue for your customers. So this is just kind of how the CloudWatch metrics look like. So that was the API that my CloudFormation stack created for the AppSync console. I'm just grabbing my API ID and filtering it based on that. So right away, we have all these metrics, latency, 500s and 400s, where 500s are like server errors and 400s are client errors. And because we also use Poly, it also offers you CloudWatch metrics out of the box. And after distributing, it's important to advertise your app and also know how it's doing with some analytics here. You can track the number of users, number of unfulfilled requests. That kind of tells you on a high level how your app is doing. And for me, I want to track my most popular language. Sorry, there's a typo. The most popular language that can be used for future features. And lastly, I want to see how much time my users are spending in my app. So you can track these analytics with Amazon Pinpoint. It allows you to engage your users with email, push, and SMS. And it's easy to integrate this as part of your app using AWS Amplify that I mentioned earlier. So let me just show you how easy that is. So in the root folder of your project, you just have to run Amplify add analytics. It'll ask you a few questions. Your Pinpoint resource name, it's going to keep it default. Keep everything default. So cool, it just created resources locally on my computer, but I want to be able to push it to the cloud. So you just run Amplify push. Now what it's doing is it created a CloudFormation doc for you. And it pushed it to CloudFormation console, and then it helps you manage your resource that way. And also tells you the state of the resources. So it looks like they're all creating. And some of them are done creating. So it should be done pretty quickly. I did, again, skip a lot of these because it does take a while. So once this finishes, we can test if we really have analytics in our app. It's cool. So now that we have both operational and business metrics, it's important to take these and analyze them and look for ways to improve your app. So with the added metrics, I can get indirect feedback from my customers to see how my app is doing. We can pretend that we've been getting a lot of tweets from our customers to be able to add German. So that will definitely improve my retention and acquisition. So let's quickly add German. I'm just going to add a new German button to my app code and add a new German language code. This is all just implementation specific, but that's how I decided to do it. So let's just test it out. Using React Native run iOS command. What this will do is just upload the app to my simulator and then allow me to test it out. This is like an example of local testing. So let's wait until it finishes loading. All right. So now we have French, Portuguese, Spanish, and German. Awesome. So let's test out the French capability. I added German. And awesome, it translated in French and also in German. So I got kind of excited when I was building this app. So when you actually click on the button, it also plays a translation. So I can show you guys later if you guys want. So my translation app now has another language button added. I just added German. And it was super easy for me to add German because I'm using the service in the cloud to do my actual translation. I didn't actually have to write my app code to do all the German translation. That's a nightmare. And since I chose to go cross-platform with React Native, I can take advantage of the over-the-air update. So my customers can get this new German feature immediately, and hopefully I can get some immediate feedback as well. So let's just summarize what we just did. I started with an idea to build a translation app. Then I designed my app to contain the language button, text boxes, and translation button, and made the decision to go in React Native. Then we moved on to develop, where I built my app and the backend using AWS Amplify and AppSync. After that, I tested the functionality and stability of my app using AWS Device Farm, where it gave me cool screenshots and videos. Then we talked about creating 2 different endpoints for our backend, one for development and one for production. And after that, I made sure I was collecting both operational and business metrics. And lastly, based on customer feedback, I added support for German. You too can follow these exact steps to build your own apps. And let me know if you guys build an app. I'll be happy to check it out. Oh, well, wait a minute. Okay, yeah. So if you want to check out the sample, you can check out the GitHub link over here.
If you're more interested about Goodreads, you can visit our website here. And if you're interested in playing with AWS technologies yourself, React Native or React, we're always hiring, so come talk to me or check out our website here. Our apps are available also on the Play Store and the App Store, and you can see actually our list feature live there right now using React Native.
So that's all we had today. Thank you.
Thank you.
And hold on. We do have a meet and greet for you to ask questions. It's 15 minutes from now. It's at the speaker lounge at the Willow Lounge, just around the corner. So just join us there. And please don't forget to complete the session survey found in the mobile app. Thank you.